Can you hear me? Does it work? Hi. All right. Not as polished. I'm very tired. It's been a very long week. Keep questions coming. I'm fine with it. Interrupt the hell out of me. This is going to be a mess. So we're going to talk about chaos engineering. I'm so sick of talking about chaos engineering, but I think it's a really important topic, and we should talk about it more, unfortunately. And it's like testing in production. I can come up here and talk about feature flagging and canary analysis all fucking day long. Like chaos engineering is a little different, so it's fun. So hi, I'm Corey. I'm the VP of Infrastructure at Datadog. I've been there about 2 years. Datadog, if you don't know it, is like a SaaS offering to do infrastructure and application monitoring for engineers. We actually do a lot more than that now. We're APM, tracing, logging, etc. Check us out if you don't know who we are. Pretty good. I like the product, but it was a customer for 3 years before joining. It's pretty aces. Our tools provide like a surprisingly deep level of insight into your applications for your engineers, and as a result, it makes things like chaos engineering far easier to kind of build and adapt and grow. It's kind of in the DNA of our company to be thinking about performance and monitoring and resiliency. So why should you listen to me? Unfortunately, you can't talk about chaos engineering without talking about Netflix. I spent 3 years at Netflix. While they're very famous for their chaos engineering efforts. That really spun out of the SRE team. I was the sole SRE for a year and a half. So they're doing interesting work. You might have heard about Chaos Monkey. Pretty rudimentary. Looking back on it now, it's like comes through, kills one of your instances, one of your nodes, etc. Very kind of old school, but really had a huge impact at Netflix as they were kind of scaling up and early adopters to the cloud. The cloud environments that they were going into were fun, would be the nice way to put that. EC2 in the early days was like not the most stable of platforms. It was kind of a mess. But there was, the goal was to simulate a loss of a system so that they could build these, this adaptive environment so that they didn't really have to worry about resiliency as much. But as they continue to scale up, the limitations of Chaos Monkey really started to rear its head. Of like, losing a node is fine, but what happens when you lose a quarter of the nodes, a third of the nodes, the entire region? Then what? And that kind of led to my two big contributions there, which were the creation of both Chaos Gorilla and Kong. Chaos Gorilla, which is on the left, simulates an AZ failure. It really is an AZ evacuation tool internally. It's how they kind of shift traffic when Amazon loses one of their AZs, which happens very rarely nowadays, but it can happen still. But it eventually became clear that that wasn't enough, and they had a global ELB outage in 2013, 2012, can't remember, and that really forced us to rethinking about multi-region availability and resiliency, which kind of led to Kong, which is the region evacuation script. And unfortunately, at this scale, it's always interesting to watch demos, and a lot of people don't necessarily have these problems at scale. They just don't operate at this scale. It's something other to start moving, a million RPS, between regions in real time while scaling up and adding resources. When sometimes like the cloud provider doesn't have those resources, like. You can't just ask for 10,000 machines. They're like, wait a second, that doesn't exist in the data center. So it's kind of a really interesting problem. But one of the things has become very clear to me after talking about this the last almost decade is that what works for them most likely won't work for you. Netflix has an interesting problem in that like a lot of their services are stateless. Makes this really easy to do. You can go blow up stateless applications all day long, and you can just load balance across new resources all the time. Turns out when you throw a CDN out of a lot of your problems and caching out a lot of your problems go away. Unfortunately, not everyone has that. And there are other types of failures that you should be thinking about. It's not just about hardware or resource overloading. It can be network latency, network flapping, buggy software. At the end of the day, there's a human problem, and here, like things break. Input variance is a huge one. Retry storms, also a huge one, especially at scale. What happens when suddenly you have 1 million customers all suddenly DDoSing you? Like it's a nightmare. Race conditions still happen all the time, and just dependency failures, like dependency trees in some of these distributed applications are mind-boggling. So it became very clear, that we need to go a step further. And there were some internal efforts at Netflix to kind of do this, but at this point, the community was also kind of catching on and really pushing forward. Which kind of brings me to Datadog. I joined the company about 2 years ago. When I joined, as a customer, you fall in love with the company, and then you kind of show up and you see how the sausage is made, and you're like, oh shit. But they were doing some chaos engineering. They had their own like chaos monkey of sorts, and it wasn't as bad as it could have been. But they were going through into like an enormous amount of growth, and so today when you look at the ecosystem, this is our service map, and at scale, it needs some love. We're working on it. We have a lot. We just have a lot of interconnectedness. Everything talks to everything. Things get a little bit crazy. When you're dealing with hundreds of services at massive global scale, across data centers, across regions, across clouds, things get very, very complicated very fast, and like the failure scenarios become very complicated very fast. So I think it's important when you're talking about chaos engineering to also talk about culture. A lot of companies that are like, we want to do chaos engineering, and then they like invest all this time and money, and they build this team, and then like the team's incredibly ineffective because the organization is just not ready to actually do it. That is not the case at Datadog. Datadog is the most chaotic environment I've ever worked at. I love every minute of it. It is fucking fantastic. Some people would truly rip their hair out if they had to work there, though. It is not for everyone. In the last 2 years since I've been there, we've gone through an immense amount of growth in terms of, we went from thousands of machines to tens of thousands of machines. We've completely containerized the environment and gone to Kubernetes. We run the world's, or at least one of the world's largest production Kubernetes installs, as far as I can tell right now. As I mentioned, the infrastructure footprint is orders of magnitude bigger, and we've also exploded the breadth of the product, from adding logs as a product, synthetic load testing, real user monitoring. The list is fairly large, and so the product breadth continues to expand, and everything's talking to everything, and dependencies become more complicated, and everyone wants to be a platform team, and so everything relies on everything now, and everything's storing state. That is the other thing here, is like 85% of our fleet has some type of state on it. And so that makes like all kinds of testing incredibly difficult. You start blowing up machines and you potentially cause outages, and pretty bad ones in some cases. It turns out state at scale is very hard to like refresh at times, because there's only so much bandwidth in a data center to like dump that many gigs of memory somewhere. And the other thing I think is important to kind of think about is, what is the goal, and is the organization aligned with the goal? For us, trust is everything, and so resiliency and availability are kind of baked into who we are, because if we're down when a customer is down, it's like leads to a really painful conversation. It's one we just want to avoid, and so this is near and dear to us, and we want to make sure that we're building resilient systems. There are some of our customers like don't bother. They literally don't care if they go down for an hour, and that's totally fine, because it really doesn't have an impact on their business. It would matter to us if we were down for an hour. So when we talk about chaos engineering, one of the things I think is important to know is, like 2 years ago, Datadog was starting small. In terms of by this I mean like schedule game days, go talk to teams, don't try and automate everything, don't try and like turn off everything, like go after the easy wins, go after your stateless applications and just get the win, right? Start to build that cadence and make people understand, build that internal communication feedback loop. If you look at chaos engineering, point one for Datadog, we had done about 160 game days over the course of 2 years. Our chaos monkey was like a Python script in AWS Lambda. It would come through, kill some nodes. About 80 services were scheduled to automatically run this. This still technically runs, but it's on its way out. And over the course of those 2 years, we killed like 10,000 instances. Great, awesome, cool. But what we were finding is it wasn't really giving us a ton of data. It wasn't really, it wasn't what we were looking for. It wasn't actually increasing resiliency outside of like the lowest barrier. So the other thing I tell people is to kind of understand your steady state. Unfortunately, I work at Datadog. We monitor everything. We know what our steady state is. If you don't have monitoring, if you don't have alerting, if you just do that, just get some level of visibility. Don't even bother with this shit. Don't even bother to try and test in production because you already are because you don't know what the hell's going on. You need to understand the steady state. I almost like wanted to come up here and just rage at the room for a long time when they were like, "What do you want to talk about?" I was like, "Testing in production is fucking stupid, and everyone does it, and they don't know what the hell is happening." Monitoring your systems is very, very important, and I think you have to. This is where the SLO, SLI initiative from Google has really there's a lot of flaws with it, I think, but in general speaking, gives you a start point to just say what is the impact of this service? What does it do, and what is how do users interact with it? And I think users need to developers need to understand that because in a lot of these esoteric failure scenarios, engineers don't even know they're happening because they don't know. They're like, well, all my stats look good. And it's like, well, it's because you don't monitor the end user. The user still gets a 500, but yeah, you're right. You're still processing data. It doesn't matter. So this has kind of led us internally to kind of rethink what chaos engineering is at Datadog. We're moving from a world of game days to experiments, and we want to be very explicit about what these experiments are. This is really kind of taking the next step and saying, well, what do we want to get out of this? What are we looking to measure? What are we looking to test? And then also, how can we do it safely? So we have, a hypothesis, a method, and a rollback. We've tried to codify what this means so that we can continue to push the envelope of what are we testing. And then to be able to, also get a feedback loop of are we making things worse? We once again looked at this list and we're like, all right, how do we codify this? And so we have these levels, and for us, level 0 is just can you kill stuff? Can you actually run Chaos Monkey? Can a node disappear? Can a pod disappear? What happens? It's surprising as we layer it on Kubernetes, there's abstractions on top of abstractions on top of abstractions, and everything's way too fucking complicated, and no one understands how anything fucking works anymore. And so losing a pod can actually cause your cluster to explode because things try to reprovision, and then it continues to explode. And there's a lot of interesting stuff that comes out of this, so it's still worth doing. But then kind of taking the next step, and for us, this is the biggest one right now. A lot of as we kind of expanded as quickly as we did, and as the company continued to double in size year over year, not every service has timeouts. Not every service has circuit breaking. There's just a lot of lack of diligence, is what I would call it, in a lot of our services. And so, and then again, we're also dealing with duplicated state across machines, across data stores, and especially custom-built data stores. And so, we're trying to look at not only partial but total loss of the network. What does that do? Network segregation, packet loss, latency, and then DNS, which is the fucking bane of our existence. So we are testing the hell out of DNS nowadays. We have a really cool talk out there, Kubernetes the very hard way. We have 9 slides in there of just all the ways in which DNS completely screws us, and it's good. Go find it. And then we kind of are taking the next step, and we're looking at CPU memory and disk and noisy neighbors. These are things that are less common, and so we didn't really prioritize them, but we think that this is the next step for us in terms of things we should be testing for. This comes into performance and bin packing and noisy neighbors, and usually we're our own worst neighbor, quite frankly, and we are of a size where we don't really share a lot of machines with any other customer, and realistically they're usually just all ours. And so this is the next kind of level for us. And then finally we're looking at the distributed systems, and we're kind of figuring out all right, if we lose an AZ, if we lose a fucking region, what happens? How do we do this? I'll be very honest with you, level 3 is AZs we kind of have, but it's only because we're lucky. Loss of a region is still something that is actively being developed right now, and the tests for it are going to be very complex and very scary. So don't jump into it. Don't even bother. Start small. How do we do this? So unfortunately, this Python script, Lambda, not really going to cut it in this day and age, especially as we move to Kubernetes. There's actually this really interesting project called Chaos Toolkit. My SREs kind of looked at it and they said, hey, we can build on top of this. It's a framework for kind of building chaos engineering tools. We've invested fairly heavily in it, quite frankly. the big goal here is that, especially again, as our footprint continues to grow, as the company continues to expand, more teams, I can't keep up hiring SREs with the rate of the growth of the company. It's just really fucking hard, especially in New York City. So everything we're doing is trying to strive towards self-service. It's no longer, hey, let's chase you for game days. It's, hey, we ask you to, do you have experiments on your project? And we just, auto blast you every Monday of like, hey, you need to add experiments. Hey, you should be testing this. Hey, this service should be level 0. It should be level 1. What are you doing? Are you moving? And then we can do reporting and data collection around that across the entire ecosystem. This is the general workflow. We do use Spinnaker. Ignore that. It's fine. It doesn't matter. But we created, with Chaos Toolkit, we have this Chaos Controller, which is a CRD on top of Kubernetes. We will probably open source this in the coming months. And then basically, you can trigger a job in Spinnaker that will read a CRD and spin up a Chaos pod, and then that Chaos pod will either do network attacks or kill the pod or kill the node. It's fairly clever, honestly. In terms of what the end user needs to do, this is it. If say, hey, we're level 0, here's my health check, and they're off to the races. This is as bare bones as it can get. It can get more complicated than this, but generally speaking, you can just clone something like this and run. And then the nice thing is that because we own the CRD, because we own the pods, we can metric the hell out of everything. So it took us 2 years to kill 10,000 nodes. This is just the last month. We killed, we've run 4,000 experiments across the ecosystem. We don't run them on weekends. We're able to create some rules around this so that hey, I'm not getting paged because we turned something off, because we were running some shit. And then the other thing here is we're able to kind of do even more engineering of hey, if we have an active incident going on, stop running this fucking thing. Just feature flag something and stop running experiments. And so we do that as well. And this gives us a chance to kind of, who are the teams we should be talking to? What's going on? This dashboard is actually much, much longer than this. There's a lot of data here, but it's kind of interesting. And we're kind of keeping an eye on what's failing. And obviously there's a noisy neighbor here and we gotta go clean it up. Or there's a noisy one here, but whatever, it's fine. So what's next for us? I think this is such an early stage. When we think about where Kubernetes is, where users are, the goal here is that this needs to be easier. Again, you can't rely on your SREs to be the ones to chase people for this. They don't fucking care. The SREs will get overloaded. It is demoralizing. You have to find a way to incentivize users to see the value in these things. Making them on call for their services is a really good start. Go do that. For us, I think we're striving towards that level 3, level 4, and we're kind of thinking, all right, well, once we get there, then what? And it is, probably not only multi-regionally, but it's probably, what happens when you have 12 regions? Can you start to dynamically shift traffic on the fly? I never want to be woken up, and that's kind of the goal here. Is I'm too fucking old and I'm too busy and I just want to sleep. So realistically, how can we continue to get these things into a state where things just auto heal? The other thing that I'll stress here is if you're thinking about doing chaos engineering, if you're not already doing it, don't let your engineers be assholes. It's really, really important. It's the easiest way for the rest of the organization to turn on you, for you to lose any kind of momentum here. This work is important. It does provide value. It does make things better. But don't go shoot a service in the head that is going to cause an outage and take 3 days to fix. That makes no fucking sense. At Netflix, I can remember teams years. Our Cassandra team waited years before they were willing to run Chaos Monkey, never mind Gorilla. And there was just a whitelist, and it was fine. And we would hound them all the time for it, but in reality, we still left them on the whitelist, and they weren't actually moving. And so, in the event of an actual failure, we probably still would have been down. But everything else would have been great. Yeah. And then, don't just hope that things will just work themselves out. Don't just hope that the Kubernetes community will save you, because they fucking won't. It is not good software. Don't depend on it. At least it's getting there. It's getting better, but it's the best we got right now. But don't just hope that this stuff is not a problem for you. Pay attention to it. You might not be at a scale where you need to be doing it, but you quickly will get there. And there's a lot of really cool tools out there that are just easy drop-ins. So keep an eye on it at the very least. And as always, we're hiring. If you want to work on this shit, come find me. It's fine. We have big, hard fucking problems. That's all I got. Easy. Cool.
Yeah. What's up, Corey?
What's up, dude?
Could you speak a little to some of the tools that are currently available, like KubeMonkey, Powerful Seal? What's your opinion?
A lot of the older tools, especially Chaos Monkey and some of the stuff coming out of Netflix is like deeply tied to Spinnaker.
Okay.
And so it's pretty hard to kind of pull those apart, which is why we ended up building a lot of our own. I think the Chaos Toolkit is like the one project out there that I've seen that is like aces and like kind of going in the right direction.
Is that tied to
It's not tied to Spinnaker.
Okay.
And I think the work we're going to open source and some of the stuff we've done upstream will likely continue to make it fairly abstract. We're probably going to move away from Spinnaker in the very near future. And so we're making sure that the tools we are building and investing in are fairly kind of lift and shift for us. And because we don't want to be tied to this stuff, and we're always keeping an eye on the community. There's like some really great work that just shows up out of the blue, and we want to be able to use it right away. But yeah, Chaos Toolkit right now is super ace.
Oh, cool.
Hi. I actually listened to a previous talk about the Python script to terminate using Lambda I think in the headquarters, New York Times. My question is, in terms of this chaos engineering, my first question is, in terms of this chaos engineering culture, how does this play between your team with other teams? I know that you mentioned that there are game days.
Sure.
How does the product team prioritize the stuff that you created, or the problems you created?
Sure. So again, we went through a fairly significant shift when I joined. I moved us to a you build it, you own it model. And so engineers are on call for their services. And so when their services fucking break, they are miserable, which is nice because I don't like being woken up again. That helped quite a bit. People started being like, well, why is my service failing? What is going on? What happens when we inject latency? And then they were more eager to come to us and schedule a game day so that we could at least start down that path. And now that we've kind of made a lot of this tooling self-serve, they're already doing it. We are running like reports internally, and we keep an eye on who's doing what. And so we'll maybe proactively go out once a quarter and talk to a team and be like, hey, you launched a new service. We realize it's pretty brittle. Maybe we should do something. But it's always about the error budget, the SLO, the SLI. And we use that a lot as well to kind of dictate, well, no more product work, right? Like your service continuously is down and you can't get 3 nines or you can't even get 2, in which case like full stop, here's what we're gonna do. Let's throw some testing at this and see what happens. And then the chaos, the automation of the chaos engineering or the chaos tooling outside of that kind of holds them true. It does regression testing by default, basically. It's pretty nice. Again, I work at an engineering company building an engineering product for engineers. I don't have to pull that many teeth here. People tend to be pretty active about these things and pretty proactive. So maybe my job's a little bit easier than everyone else's right now.
Okay. Actually, my second thing is about the stack. So I was chatting with Gremlin about their take on the serverless movement. Like serverless is really getting big. They don't actually, like the service mesh, serverless technology, Lambda stuff, right? So they don't actually have very concrete commercial solution for that kind of problem scope right now.
Sure.
So in terms of your chaos toolkit, how does it play with the serverless stuff?
So we don't use a service mesh right now. We run dozens of Kubernetes clusters in production. We're using Cilium as a foundation to do cluster-to-cluster communication and transport encryption. We're looking at Istio pretty actively. But we've also been talking to the HashiCorp folks. I think what they're doing with console right now is kind of interesting. It's a little more simple, a little more easily usable by the engineers. It'll probably be Istio just because there's some stuff we would like in terms of visibility and functionality and circuit breaking and whatnot. But there's, we're looking at them and we're evaluating them. We run a flat network across all of our clusters right now. It's fairly complicated and it's clusters of clusters. We have this like meta cluster concept. Happy to connect you with the teams if you want to dive deeper there. It gets fairly in the weeds fairly quickly. Our network stack is a little insane. But generally, by running a flat network right now, we don't usually have to worry about this at that level just yet. When we do introduce the service mesh, things are going to get more complicated, like significantly more complicated.
Cool. Thank you.
Yeah.
So yeah, we're using actually very recently we started onboarding Datadog. Yeah, amazing product really. I mean, I've been a big fan of Datadog for a number of years. Firm I work for, it's like a financial firm, and it's been quite a task to get Datadog onboarded.
Yeah.
One of the questions I have, if you don't mind me asking, is how big is the SRE team?
At Datadog, 15 right now globally. We usually don't embed. In certain use cases, we will. We'll go sit with a team and work with them. But I'm not building a NOC.
So you guys are mostly like on consulting basis for the other teams.
Yeah, and my SRE team looks more like a software development team than it looks like a sysadmin team.
Sure.
Some of them have that background, but in reality, most of them are software developers.
Yeah, sure.
The goal here is to build tools that empower everyone else to do their job better, not to do it for them, not to be a crutch, certainly not to be a NOC.
Sure.
It's 2019. If I have to wake up and run a run book, like we're already fucked. We've already blown through our rubber budget. We're already at 2 nines. It's like a nightmare. So in reality, like I just think that approach is like not sustainable. I have this incredible monitor tool and alarming tool that like should let me auto correct and auto react, within seconds. Versus let's page you and then I'm going to sit there and hit sleep for like 4 minutes until I actually get up, then go get my laptop and log in, then figure out what's going on. And like, it's fucking insane. We'll never hit the availability number. Or, staff around the world follow the sun and then someone's just sitting there staring at a graph 24/7. That's insane. We have a monitoring system. We have alerts, like let it do its thing. Script the hell out of everything. Again, it's 2019. It's not 2003 anymore. I'm a little opinionated about this, sorry.
Thank you.
Yeah. Cool. All right.